So now we will see our second problem. The second problem is turbulent flow over a heated cylinder. So in tutorial 4, we saw laminar flow over a heated cylinder, and we had some parameters. Based on that, we modeled our simulation and got some results. We will do the exact same thing, but for turbulent flow. So the parameter that dictates whether the flow is laminar or turbulent is the Reynolds number. For external flow, the Reynolds number for laminar flow and the Reynolds number for turbulent flow is different. So here, in the previous problem, for laminar flow we had Reynolds number 100. Now we have a Reynolds number 10,000, and based on that we will try to model our problem. So as you can see, the parameters, the working fluid right now is air. Our cylinder diameter is 2 inch. Cylinder wall temperature is 80 degrees C. Inlet velocity will be based on our Reynolds number. Right now the Reynolds number is 10,000, and inlet air temperature is 20 degrees C or 298 Kelvin. We have to find the contour for velocity, temperature and pressure at the plane. We have to find out the plot for velocity, temperature and pressure at D, 2D and 3D downstream location. We have to find the surface heat transfer coefficient, average Nusselt number and total heat transfer for turbulent flow. In the geometry section, we have to make the domain, the same domain that we made in our laminar flow problem. So we have a cylinder diameter 2 inch. The length of our fluid domain is 30D, that is 60 inch. And the width of the domain is 15D, that is 30 inch. And the height of the domain is also 15D, that is 13 inch. And the length of our cylinder is 5D, that is 10 inch. And the diameter is 2 inch. So here in the laminar flow problem, we already developed our domain. So we will use the same domain with the same technique. You can check the previous tutorial if you have any question or if you don't know how to develop this domain. So first of all, you develop the cylinder and you extrude it. Second, you develop the domain and extrude it, and finally you cut this cylinder from this domain, then you will get this fluid domain. So that is the geometry and the domain. You have nothing to do in this section, and after that you have to do the meshing. So we will do the same meshing, the same procedure for laminar and turbulent flow problem. So we already developed our meshing in laminar flow problem, so we will use the same meshing. So we will use pitch conforming meshing method, and we will use the inflation layer as we saw during our mesh generation process, and we will name the boundaries. So this is the inlet boundary, this is the outlet, and this 4 wall is the symmetric wall, and finally the cylinder wall. So this is the meshing. We already have done the meshing. So now we can go to the case setup and we will see how to add different turbulent model and how to give boundary conditions and how to set different parameters for turbulence, and we will see the result and we will compare the result with laminar flow.